Hi there, and welcome to our session here at Microsoft Ignite. Today we're going to be talking about AI on the edge with Microsoft Surface.
I'm Fred Balsiger. I work on the Windows Silicon System Integration team.
And I'm Frank Buchholz. I lead technical marketing as part of the Microsoft Surface marketing team. So Fred, this is our second year in a row that we're actually together. Last year we did another session on AI and Microsoft Surface and the emergence of new technologies that are now in the Surface Pro 9 5G. But I think today we're going to talk a little bit about some updates. But I think it's important that we talk first about where we came from or how we kind of started, and maybe also give a link back to the previous conversation that we had, as well as some conversations that a couple other of our coworkers have had across this past year around Surface and AI. So you can check those out below. But for one thing that I like to dive in, and I see this Moore's Law, and sadly, Mr. Moore from Intel passed away this past year, but his law has been very true to form. And so essentially Moore's Law dives into the idea that the number of transistors that you can pack into a single piece of silicon essentially doubles every 2 years. And so we've seen this essentially exponential growth. And if we look way back in the early, 1970s, you could pack about 5,000 transistors onto a piece of silicon. But Fred, maybe you can tell us a little bit about what is an actual transistor?
Right. I mean, simply put, it just starts and stops the flow of electricity. I'll leave it at that.
Yeah. So, and by stopping and starting that flow of electricity, you essentially have a 0 state, which is stopped, or a 1 state, which is to keep the electricity flowing. And because computers still to this age or to this day talk in zeros and ones, that's how you represent that piece of information. But in the past, where you had to go from, say, 5,000 to 10,000 transistors on a piece of silicon, all the way up through the generations and maybe around the year 2000 when the Pentium processor came out and Intel started to pack in more essentially cores or more processors into those pieces of silicon. But then when we announced the Surface Pro 9 5G with its Qualcomm 8CX Gen 3 processor, there were 10 billion transistors in that silicon. And at about the same time, the M2 Max from Apple came out, and it has 67 billion transistors inside of it. Now, I'm excited to look at what Qualcomm Snapdragon X has to offer, because that's the next generation of essentially these pretty amazing pieces of silicon where we start to pack the transistors tighter and tighter together. In fact, I think that's a 3 nanometer piece of silicon. So that means that these transistors are literally 3 nanometers away from each other, which boggles my mind as how we can do that. But along that line, what we start to see is that people start to say, well, I've got this piece of silicon, I can do more with it than just putting an actual CPU on it. That CPU essentially that processes those scalar pieces of information and line by line execution, I can instead start to put things like a GPU on there, essentially a graphics processing unit. I can put in a modem. I can put a Wi-Fi controller. I can put a lot of different pieces on there. And one of those pieces that I can actually slide over onto this piece of silicon is an NPU. So Fred, maybe you can tell us a bit about the NPU.
Sure. An NPU is just a neural processing unit. It is a piece of silicon that is uniquely designed to run AI workloads. I think we're going to talk a little bit more about it later.
Yeah, no. So I'm super excited about this NPU piece. But while we're on this slide, I also want to point out that we have this thing called a TPM. And a TPM is essentially like a security processor. A security processor that is usually discrete, meaning that it usually sits somewhere on the motherboard. But what we're doing now is we're actually bringing that into the silicon of the chip itself. Because there was this kind of fear in the past that people would actually sniff the bus. And so I don't recommend you go out and sniff any buses, but the bus essentially being what the chips plug into. And if you read the data that was transferring from the CPU to the TPM, you could essentially read the secured information that they were essentially sending back and forth to each other in an unencrypted way. Well, now if you actually put it on the silicon itself, there's no way to sniff that silicon. Again, don't do that at home. But in this piece is that now you have a much more secured system, and we actually call that Pluton. And so this is something that we actually have built into the Surface Pro 9 5G, along with a number of other pieces of technology out there. But this helps to enhance our chip to cloud story. Essentially, when you're putting security at the chip level and you're burning it into the silicon itself, now you have this way to protect this data that is essentially passed around that piece of silicon in that space. It just brings us to a whole new level of where we can drive chip-to-cloud-based security. But speaking of that, we now have these ideas that we have these different pieces of technology, from a CPU to a GPU and now an NPU. And so we've built up this slide that maybe Fred can talk a little bit about.
Certainly, I've talked a lot about this slide with other audiences before, and it seems to resonate very well. But if you think about these three processors, we have the CPU, which does scalar operations. It knows how to deal with numbers. After that, you have a GPU, which does vector operations. It knows how to deal with arrays of numbers. And then finally, of course, you have your NPU, which deals in tensors or arrays of arrays. And so this has always worked pretty well to try to explain what these different kind of processors are doing.
You know what I like about this, though, Fred, is the idea that, we went from a world in the past and maybe the early 1990s when we just had CPUs. We had CPUs that were essentially just executing a line at a time, no matter what you fed them. But along comes Jim Clark, and he at Stanford goes out and invents this idea of what a GPU is. And GPU and being able to compute polygons or compute graphics. And it brought in a whole new world of being able to bring, visual effects like Jurassic Park and all these kind of things that were out there in the industry. And then what happened is they decided that, hey, let's take that power of the GPU and put it into a PC. And companies like NVIDIA come along and start producing some pretty amazing technology. And now we see NVIDIA starting to play into that AI game as well. But the cool part is that the NPU, we go from this generation of a GPU and how powerful a GPU, and we've all seen how powerful GPUs can become. In fact, they can probably be more than the value of the PC is to that card that you have to buy to put into there. I know I paid for that for my son on a number of different times for his gaming rig that he needs. But now we have this new generation, or this new kind of forward path that we have of, like, we're at the beginning. It's like the 1990s all over again, but we're now at the beginning of these stages with the NPU. So pretty amazing times that we live in. I think the cool thing that I like to point out with this particular slide is, with an NPU, we essentially have the idea that without an NPU, the device, the CPU and the GPU have to do all the work. And then a lot of times we see that with new things like Teams and video processing and having 49 people on the screen simultaneously, all of these technologies put a pretty heavy workload on our PCs that they've never seen before, especially during COVID when we were in video conferences all day long. Now you go from your PC being something you write a Word document on to being your video teleconferencing device and being able to have all these different workloads on it. But what we start to see is, if you have the right tool for the job and you can offload some of those pieces, like essentially eye contact or voice focus or live captions, and you can offload onto the right tool for the job, we start to see some pretty amazing capabilities. And maybe you can talk about what your team did in order to build these new technologies.
For sure. I was fortunate to be part of this kind of effort, but basically, starting in the Surface Pro 9 5G, but then expanding out to many other machines.
Yes.
We shipped a bunch of video and audio kind of AI features, again, running on the NPU. And so we did some things like automatic framing, portrait blur, eye contact, voice focus. We're all part of this Windows Studio Effects suite, and we're going to continue to invest in this.
The example that we like to show here in this slide is that, let's say we were just focused on video framing of somebody's face. We just wanted to be able to find their face in a field of faces, or a field of essentially data. And in order to do that, if I was to ask my CPU to do that, it would be 20 watts of power just to do that particular computation, which is, again, why we started to see through COVID a lot of devices getting very warm because they were having to do a lot more than they were ever expected to do in the past. But what we actually see that is, if you offload that capability that is now in Windows Studio Effects just to the NPU, you're now talking about less than 0.1% of the watt in order to provide the same type of computation. So this is doing exactly the idea of, like, hey, let me make sure I have the right tool to do this new job, and to be able to essentially focus in on the idea that we have a new world in front of us. And in fact, that new world is available on this Pro 9 5G today, as well as a number of other devices that are using the Qualcomm 8CX Gen 3 processor.
That's it.
So thanks to all the work that Fred did, as well as the Windows System Silicon Integration team did on Windows Studio Effects, we now see that in the Surface Pro 9 5G. And now the idea of being able to use the right tool for the job really starts to come into play. But now let's transition to where we want to talk about the future of AI, and essentially how we can see the development of AI applications and other pieces. So as we transition our set here for us to talk one-on-one, let's play a little montage of videos about what is built into Windows Studio Effects.
I'm going to start with audio blur. You'll notice as I'm talking that the noise in my house is picking up. So there's a kitchen fan running, there's some music playing, but with one click, audio blur eliminates that noise, and now all you can hear is the sound of my voice. Our eye gaze correction technology has also been taken to the next level. With eye gaze correction, I can be looking at the video feed, and it looks like I'm looking directly at you. With our new Cinematic Director feature, the camera will track me no matter where I am in the room, whether I'm sitting at my desk or standing up and walking around. This is great for people who think on their feet and like to walk around or talk with their hands while they're brainstorming or in a meeting. I love it because even when I'm farther away from the camera, it still keeps me crystal clear with super resolution.
All right, welcome to our adjusted set. I have our little homage to Between Two Ferns. Maybe that's a inside joke that we have here, but Mr. 𝗦𝗲𝗀𝗸𝗲𝗍 is certainly, I'm a big fan. So, but let's start talking a little bit about AI.
Let's do it.
So for us here in Microsoft, Copilot has been a big topic. It's a big buzzword, but it's also our future, as Satya has kind of pointed out, our CEO. And, you know, for us, we like to think like a big question that a lot of people ask me and is how are Surface devices essentially optimized for a Copilot-based experience?
Right. You know, so with Copilot and Windows and Microsoft 365, it all comes together very well with Surface. Like Surface is leading the way with input, right? So this is touch gestures, this is, you know, voice commands, this is pen input and whatnot. And I really think even adaptive accessories. And so I think they're doing a great job at kind of leading the industry with how we think about input as we embrace all these technologies.
Yeah, I mean, I hear exactly what you're saying. And for us, it's always been this idea that it's all about these different modalities of how we drive, you know, and talk to our computer. You know, it's how does a human interact with the computer and through natural languages. So all these different pieces to me is really what drives interaction with Copilot. The other piece would be is that developers are using Surface devices to develop Copilot because it lights up each of the modalities that they're looking for, from pen to touch to voice. Who knows? Maybe in the future, we could even see a gesture-based computer, not saying anything towards any indication of where we're headed, but already we have technologies like Windows Hello. So our ability to interact with computers really will be driving in the future towards the idea of what is local AI compared to what is cloud-based AI like Copilot. And speaking of that, you know, we see this idea that when I have an NPU on a computer and that NPU can run these amazing capabilities like Windows Studio Effects, you know, what is the advantage essentially of being able to run locally compared to being able to run in the cloud, like on an Azure cloud model that's out there?
Yeah, right. And so we're seeing like three huge advantages. They kind of falls into three buckets, right? So first off, you get your security, right? If I'm not round tripping the cloud, I'm not, you know, everything that's happening from an AI model is happening locally on my device. The next thing is running it on the NPU, as we kind of touched on, it's much, much faster. So when latency is of chief concern, like when you can't afford to do things around to the cloud, you want to run it on the device. Right. And so you got your security, you got your latency, but another big one that isn't always obvious is economics. If I'm not hitting the cloud, I'm not spinning some meter that's charging me some money. I'm not going to run out of credits. I'm not doing any of that stuff. And so those are kind of the three main reasons today why people are really leveraging AI models on the NPU.
Yeah, no, I've heard these discussions on like ChatGPT being like the 500-pound gorilla that just does everything. But sometimes you don't need everything. Sometimes you just need a small subset of an engine that can look for a particular field of data or through a field of data and find that essentially that needle in the haystack. So, and find it very fast and efficiently without having to rely on the cloud in order to do that.
That's right. And then, you know, relying on the cloud. So like one of the advantages of things like Windows Studio Effects is the nature of how they work. Background blur, voice focus, automatic framing. If you can run that on the NPU, that's advantage because you can have a consistent workload, right? So a lot of these things, you talk about ChatGPT questions and stuff, that's very bursty. That's go to the cloud, run an AI model, and come back with an answer, as opposed to sustained AI models that are running on the chip.
Yeah, and if I was in a mission critical or real-time operation, I don't have the time to deal with that latency.
That's right.
I need the answer here and now. And I think in the future, we'll see many more commercial workloads being brought in specifically to what we could load into that silicon that is essentially dedicated to the NPU in the future. You know, I think that what we start to see is, you know, I guess I have this question though, is how does the integration of AI and Windows technology and Surface devices contribute to the overall user satisfaction and efficiency in both the personal side, like being able to maybe erase your mother-in-law from a picture, to more of the professional side of like, how do we drive more, hardware-based AI into our devices?
Well, I think, and this might not be the perfect answer, but I think one of the unique things we have is, we have an operating system that is Windows, we have an Azure cloud presence, and now we have, our great Surface product line.
It's like a closed loop.
Exactly. As I was going to say, like it's a smaller development loop, right? So it
Right.
gives us permission to iterate faster and to try new things and fail faster too, if we need to.
Yeah, no, I mean, I love that in that I always think of that, and from a security standpoint for Surface, it would be that if there's a problem with the Surface device, whether it's Windows or whether it's a Dynamics or whether it's M365, we can reach out to those developers. They're probably in the building right across the street, or they're in the same space that we are.
Yeah.
And because of that, we can essentially push an update through Windows Update all the way down to the firmware level on a Surface device in order to keep it secure. I think that the NPU side can be the same as well, and that how do we drive AI in the future? We can provide updates, we can provide other modeling pieces, but we can also take efficiencies of how we designed our devices. I also think of it also of like, how do we think about like power consumption across our device? Because we understand the Windows power consumption and the power consumption of our device, we can couple these pieces together. So, there's a lot of efficiencies that we can take into granted. So for me, I get now that, how it is that we're, the efficiencies or the value of the NPU and the workloads that it can take on. But how does an application, like if I have an application and it's built for an NPU, how does the operating system know that this LLM or large language model is built for the NPU and not the GPU or not the CPU?
I mean, this is a good question. And sometimes the answer is it's the nature of the model itself, right? Like if we just talked about sustained workloads as opposed to a ChatGPT query, right? And so because of that, the nature of the workload, you would understand as you're building the app. Developers today understand there are frameworks and standards that if they abide to, their apps are going to end up running AI models on an NPU. So for example, we showed up at Build and we talked a lot about the Onyx runtime and execution providers. And so we had hands-on lab. We showed people how you could do this. And so, of course, it's not the wild, wild west. It can't be. Right. If I have Windows Studio effects on, I don't want some other AI model by some application coming in. And so that obviously needs to be policed. And that is done through the operating system driver models.
But is it fair to say that an NPU, like a GPU, is essentially a generic processor that I could load literally any AI or purpose-built application for that NPU into its I
think purpose-built was the right word. Yes.
Yeah. So for me, it's the idea that just again having that right tool for the job. It's like you have all the tools on your pegboard and you reach for the right one because this is the tool that I need to use. If I need to play a game, then the GPU is great. But if I need to run an AI model, then that NPU is the right tool. And that's how essentially it sounds like the operating system knows that. I guess a follow-on question would be with the example of Windows Studio Effects, once I click on Windows Studio Effects, like I want to turn it on and use it, is it automatically loaded into the NPU at that point?
Effectively, yes. That is how it works.
Yeah.
And so, if we think about all these competing AI models, we're clearly going to have some heuristic. If I'm on a video call and I've asked to use my Windows Studio Effects, we want those to take priority on NPU, right?
Right.
The second I get off that and I'm doing some type of local drawing and I want to engage some stable diffusion model, well, then I think that, the operating system driver model and other heuristics we use are going to have to be welcome the use of the NPU to that application.
Yeah. It sounds like a lot for the operating system to now take on. Like, how does the Windows actually literally logically handle the switching between a CPU-bound task and a GPU-bound task, and now this NPU-bound task? Like, literally, it sounds pretty complicated.
So you're right, it is, but they all work in concert, right? And so they all work together and they're all purpose-built. We talked about scalars versus vectors versus tensors kind of thing. And so, you would like to believe that the Windows operating system would, being aware of what type of things it's running on with the right set of drivers and stuff, they'll all work well together. And of course, you have to have something overriding body to police it. And the CPU watches what the NPU is doing occasionally. And, and it's tricky.
I all of a sudden got this picture of like a cook that's got like 5 different things that they're cooking. And they can do all these things in parallel, but they're just checking on each of the pieces. But in the end, they plate it up and dish it out all as one, plate of food. And it'd be like the idea that how the CPU, GPU, and NPU can work in concert with each other in order to produce, one application that is threaded in many different directions.
Yeah, I like that.
Yeah, for efficiency. So, given that we've got, essentially this idea that we've now got this amazing capability of now this NPU that can essentially be the right tool for the job, what can a developer do? And just this past year at Build, I think you announced quite a bit of work. So maybe you can kind of review some of those announcements.
Absolutely. And, it's public because we announced it. We got to celebrate some great developer scenarios. But, the WhatsApp app from Meta came native to Windows on ARM.
Right.
And so when that happens, that app uses standard video and audio channel on Windows 11. So they got Windows Studio Effects for free. There was nothing they had to do. It just lit up because, again, the WhatsApp uses video and audio. And
so they're essentially using it much like an API where they say, I love what Windows Studio Effects is doing with background blur or portrait blur or voice ID in those different spaces. How do I plug that into WhatsApp?
Right. And it just lit up for them. They didn't do anything, right? Because those were what I like to call inbox models, meaning Windows 11 is going to ship with AI that's just going to happen.
Right.
And that typically works an advantage for the developer, right? But then we had another great customer too. We had Skylum that has their Luminar Neo photo editing software. And they're super interesting to me and to us, to Windows, for two reasons. One is they didn't need anything for free. They had all of these own AI models. They have AI models that do things like remove power lines, soften edges and whatnot. And these things took a long time. And so they work closely with us leading up to Build to showcase the fact that some of their models that can take 2 minutes because they're running on a CPU or a GPU can take seconds on an NPU. And so it was fun to showcase them and all of their AI tech that they ported over using the Onyx runtime and standard frameworks.
Right.
But it's fun to celebrate that they were able to do that. The second thing that's super interesting about them is their customers, their use case. So these are typically photographers that are going out in the nature, taking pictures of things. They can't afford to or don't have access to the web.
Yep.
And so the fact
usually where there's grizzly bears, there's probably not a lot of connectivity.
That's right. And so the fact that they can take their AI models and do their video processing locally on the machine is a big win for their customers. And so it was a win-win for everybody.
Yeah, I mean, talk about literally turning any space into a video editing and video capture space.
Yeah.
So that's amazing. And all of that because of being able to kind of power that. And they're not having to sit there while the grizzly bear is probably running after them. That takes minutes. But if you only had a second, you can do things faster.
There you go. Perfect.
Saving lives. No, don't. But towards that, I think that it sounds like the work that they did is they had to use some sort of tooling or some sort of, how did they create all that?
Yeah, and so, we're trying not to boil the ocean for developers here, right? So the Onyx runtime is an open source, cross-platform framework that people can use today on Windows to go ahead and, inference your AI models. The one thing we did for Build was we knew that each IHV, because maybe we haven't talked about this, but Intel's coming out with an NPU soon. AMD will have an NPU. Of course, they call them something different, but all of our favorite IHVs will have NPUs. And so one of the things we did was we worked with them to make sure each of one of these people had what we called an execution provider, which basically Onyx knows how to work with. What that does is it lets you talk to the natural language of each one of these NPUs. So Qualcomm has their snappy QNN, Intel has their OpenVINO, AMD has their Vitis. And so if you can have an execution provider that Onyx Runtime knows how to do it, you're now running AI models on NPUs across silicon. And I think that's super important to have a consistent developer story.
Yeah, I mean, it sounds like what we did with like the X framework or Open GL framework, and how that essentially said, no matter what graphics card or what video system you're creating for, it's all going to work because you have this, unified framework.
That's right.
It sounds like we're doing this now for all the different NPUs that are out there from Intel, from AMD, as well as Qualcomm coming out.
And of course, I recognize it's kind of bifurcated system because we have to have different execution providers per silicon, but we're working very closely with our DirectML friends. And so pretty soon we'll have a consistent, machine learning layer.
Just to kind of become easier and easier.
Exactly. And so we're making great strides in that direction. I hope that by Build next year, we'll be able to announce an even simpler story for developers.
Well, I imagine in the beginning when the GPU first came out, there were very small framework of tools to be able to program towards it. But look how we've come and look how far we've come. And every game developer out there is using, imagine how fast they can create games these days because of that, and where AI will head into the future as well. So Fred, let's just wrap this up. So what can a customer do today, somebody that's sitting at Ignite, what can they do today to make their business ready for this AI forward future?
Yeah, so we have many devices today that are AI powered. We're going to have many more coming soon. And so I think it's grab a device, it's start playing around with it, it's learn, and it's engage.
Fair to say that what they see on like the Surface Pro 9 5G or even the 2023 Dev Kit, they could develop for that, and that would kind of sense apply to what we would even see in the future.
I think that's right. I don't think people are blocked anymore.
Yeah. So, and the other piece would be is that you can explore the development of AI solutions for an NPU by going out and checking out these accelerated workloads on Windows Studio Effects. And you can actually see Windows Studio Effects today on the Surface Pro 9 5G, as well as the new Surface Laptop Studio 2. We encourage you to stop by the expert meetup space to discuss AI further with us. I think we're actually going to be in that space and get your hands on these amazing devices. We also encourage you to check out our demo session with AI workloads on Surface that we're going to do as well here at Ignite. It's just an exciting time.
Yeah.
I think this this time next year, I think we're going to have a huge story to tell around other devices and other pieces. So I'm super excited. So Fred, thanks so much for joining me. And we'll say bye for now.
Thanks, everybody.